Welcome to Math Olympiad. Let's solve the IOQM 2022 paper now. The complexity of the IOQM is every year is increasing. So let's solve this problem and see how it is. Uh, as you know, there are different marks for the questions in IOQM. Okay. So in this paper, 2022 paper, first 10 questions carry 2 marks, then 11 to 22 carry 5 marks, and 23 and 24 carry 10 marks each. Okay. This is the pattern. Okay. In this video, we'll solve 1 to 10 questions. Okay, that is 2 marks questions. We'll solve them. Out of the 10 questions, 1 is actually wrong. So I will just ignore it. So 9 questions will be there in this. Okay. 1 question is given wrong by the IOQM. Okay. So 9 questions will solve in this. Let's start. Okay. A triangle with ABC, a triangle ABC with AC equal to 20 is inscribed in a circle. The tangent to T to circle is drawn through B. Okay. The distance of tangent from A is 25 and that from C is 16. If S denotes the area of the triangle ABC, find the largest integer not exceeding S by 20. Okay, we need to find the S by 20 basically. Okay. So what we need to know to solve this problem is one is alternate segment theorem. Okay. Simply it states this is the statement, but how it is there is a circle and there is a tangent DE at C. Tangent is touching the circle at C. And at C, if you draw a card, okay, that is either BC, you call it, okay. If it is BC, the BC is making an angle, the green angle here, okay, at C. This is equal to the angle BC makes on the circle on the opposite side, okay. So BC is making an angle at A, this is green, okay. These two are same basically, okay. If BC is making an angle this side, okay, if the angle is this side, then it is not same, okay. So remember these two are the same, okay. And similarly at C, AC is the card and AC is making an angle this pink color. Okay, this is same as angle B here. Okay, so this is the alternate segment theorem. Okay, remember this. This is one thing you should know. And you also know relation of sine of angles and sides in a triangle. Okay, that is and circumradius of the triangle. I think you know this a by sine A equal to b by sine A equal to c by sine A. Okay, so similarly, I mean, if it is circumradius you want to calculate, then r equal to a by 2 sin A equal to b by 2 sin B equal to c by 2 sin C. Okay, or sin A equal to opposite side by twice the radius. A by 2 are basically that way. Okay. Now other one you should know is circumradius also equal to product of three sides by four times of area of the triangle. Okay. So these three things you should know to solve this problem. Let us first construct the diagram. Okay. Um, there is a triangle ABC. Okay, it is inscribed in a circle. Okay. There is a tangent MN. Okay, touching at B. Okay, and the distance of this tangent from A, that is AM, is 25 and CN is 16. Okay, this is what is given. We need to find out the area of the triangle. Okay, and then S by that area by 20. That's what you need to find. Okay, so AC equal to 20, AM equal to 25, and CN equal to 16. This is what is given from alternate segment theorem. Okay, the angles here, right? ABM is equal to C, right? This is what we learned. And CBN, that is this angle equal to A. Okay. So I just added theta and alpha there. Okay, you can understand. Now sine C equal to sine C, that is this one. Okay, which is same as this. Sine C equal to AM opposite by hypotenuse AB. AM by AB. Okay, which is also equal to AB by 2R. Okay, circumradius principle, right? Okay. So which implies from these two angles, AB square equal to AM into 2R. AM is nothing but given as 25, so it is 50R, which means AB equal to 5 square root of 2R. Okay. Similarly, from sin A, which is this one, okay, sin A is this one, right? A is this one, sin A equal to Cn by BC, opposite by BC. That is also equal to BC by 2R. So BC is 4 square root of 2R. Okay. Now, R is also circumradius of ABC. So R equal to product of three sides, that is A into B into C, divided by 4 times the area of triangle. Okay. So AB into BC equal to AB into BC equal to 20 into square root of 2 hours into square root of 2 hours, that is 2 hours, so which is equal to 40 hours. AB into BC into CA, because CA is given 20, right? Equal to 800 hour, we know it. Now, it's simple. R equal to AB into BC into CA by 4S. S is the area of the triangle, which is equal to 800 hour. This is we calculated above by 4S, which implies S equal to 200. Okay, now we need to calculate S by 20, right? So S by 20, largest S by 20 is, straightforward you can get is 10. It's the value. Okay. So this is medium. If you know the uh, formulae which are given in the first page, then this is easy, but okay, I would say it is moderate. Next, in a parallelogram ABCD, the point P and the segment AB is taken such that AP by AB equal to 61 by 2022, and the point Q on segment AD is taken such that AQ by AD is 61 by 2065. Okay, so we need to find out. Let's draw the diagram first. Okay, this is a parallelogram. Okay, A P is on AB, Q is on AD. Okay, now AP by AB is given and AQ by QD is given. AQ by AD is given. Okay, now PQ intersect on AC at T. Okay, now he's asking what is the value of AC by AT. Okay, this is what you should find out. AC, that is diagonal, by AT. Okay, so AB equal to CD, let's say AB equal to CD we know already. Let's say this is L, and BC equal to AD we know. BC equal to AD. Let's say this is B. Okay, now these are the given values. Okay, so AP equal to, since AB equal to L, I will call it 61L by 2022. Similarly, AQ equal to 61B by 2065. Okay. Now I am drawing a parallel line to PQ. Okay. BL and PQ are parallel such that it touches the AD at L. Okay. And it passes through this one, touches at X. Okay. Now APQ, APQ and ABL are similar triangles. Why? You know A is common angle, and these PQ and BL are parallel lines. So angle here, angle at P is equal to angle at B here, angle at Q here is angle at L here. Okay, so they are similar triangles. So use the similar triangle principles. AB by AB, AB full by AB equal to AL by, that is AL by AQ. Okay, so this is given values. AB by AB is given as this one by R. I mean you can find out from this. So L by 61 L by 2022, which is equal to AL by 61 B by 2065. So with this, you can calculate AL, which is equal to 2022 B by 2025. Okay. Now, AT by TX is also same as AP by AB. AP by AT by AX, sorry. AT by AX equal to AP by AB. Same ratios, right? Because they are similar triangles, which is equal to 61 by 2022. Okay. Now, note down these values. AT by AX. Okay. Now, triangle AXL is similar to triangle CXV. Why? This is also angle theorem. So, angle here is same as angle here, opposite angle. And since BC is parallel to AD, the angle here will be same as angle at L. The angle at A is equal to angle at C. Right? So, they are similar triangles from angle theorem. Okay. So, here AX by CX. Okay. You can see take the common letters from here. AX by CX equal to AL by CB, which is equal to AX by CX equal to AL by CB. AL by CB we already know. Okay. AL we know already. Okay. And we know BC, which is L. So from this, sorry, BC is B. So from this we know that it is 2022 by 2065. This implies, okay, AX by AC equal to AC. I am writing it as AX plus XC. Okay. AX plus XC, right? AC is AX plus XC. Okay, now I'll just divide numerator and denominator with AX. I will get 1 by 1 plus CX by AX, which is equal to same value, right? This is AX by CX, right? 2022, sorry, 1 by 1 plus 2022, which is nothing but 2022 by, sorry, 1 by 1 by 1 plus CX by AX is here 2065 by 2022. So if I substitute that value, this is what I'll get. Okay, 2022 by 4087. Okay, now from these two values, okay, I can get AC by 80, correct? Which is equal to 4087 by 61, which is equal to 67. This is the value. Okay. Yeah, this is little bit complicated. You need to understand again geometry. You have to play with geometry more. Moderate. Next problem is the trapezoid ABCD. Let's draw the diagram as we read it. Okay, ABCD is the trapezoid, and internal angle bisector at A, okay, intersects with the base BC at E. Okay, so this is the angular bisector. So alpha and alpha equal angles here. Okay, then in ABE there is a circle inscribed. Okay, it meets AB at M and BE at P. Okay, find the angle DAE, that is alpha. Okay, if AB by MP equal to 2. Okay, okay, first is given that AB by MP equal to 2. Okay, now let's put the sides. Okay, here from A there are two tangents drawn, so these two will be equal. So XX. Similarly from E two tangents, so ZZ, and B two tangents, so YY. Okay, so MP equal to AB by 2. Okay, which is AB is nothing but X plus Y by 2. Okay, now AD is parallel to BC, so and A is the transversal. So DAE, that is alpha, equal to AEB. This is also alpha. Okay, then X equal to Z. Why X equal to Z? Because this is also alpha. From E there are two tangents drawn. Okay, from A two tangents drawn with the same circle, and the angle made at A and E is alpha and alpha. So obviously X and Z will be same size. Okay, now BAE is similar to BMP still. BAE is similar to BMP. Why? Because this is X plus 5, Z is nothing but X. So X plus 5, this is isosceles triangle here. B is a common angle, and in BMP also B is a common angle, and it's isosceles triangle. So other two angles will be same as alpha and alpha. So this is a similar triangle. Okay. MP by AE equal to BM by AB. Okay. MP is given as X plus Y by 2. Okay. From here. Okay. So X plus Y by 2. AE is nothing but 2X. AE is 2X because Z is equal to X. Okay, equal to Bm. Bm is y by x plus 5. So this implies x plus 5 whole square equal to 4x5. So we can say that this means if you take this other side, x minus 5 whole square equal to 0, which means x equal to y. If x equal to y, what happens? ABE is a equilateral triangle, right? All sides are same, which means each angle that alpha is 60 degrees. Okay. DAE is nothing but AEB, which is 60 degrees. Yeah, I think this is easy. Next. Starting with positive integer m written on a board, allies plays the following game. Okay, m is written for allies. Okay, in each move, if x is the number on the board, in this case m, she replaces it with 3x plus 2. That means she replaces with 3m plus 2. Similarly, starting with positive integer n written on the board, Bob plays the following game. Okay, he plays in a slightly different way. Each move, if x is the number on the board, he replaces it with 2x plus 7. So he has n on the board, so he will replace with 2n by 2n plus 27. Okay, given that Alice and Bob reach the same number after playing 4 moves each. Okay, they play like this 4 times. Then what is the value of m plus n? Okay, so this is easy. In 4 steps, Alice will make 3m plus 2. Then this is the m value number on the board. So again, she will make it 3 times, then plus 2. Then 3 times plus 2, 4 times basically, right? And same thing, Bob actually makes it 2n plus 27 4 times. Okay. So now these two are equal. That's what they are telling. So you just equate it, simplify. You will get 81m equal to 16n plus 325. You can simply start substituting with the smallest, what they asked is smallest possible value. So try to replace n with 1 and see if you get a integer for m. So the minimum values will get is m equal to 5, n equal to 5. This is the minimum value you'll get 5 by observation. Okay. So m plus n equal to 10. I think this is easy. Next. Let m be the smallest positive integer such that m square plus m plus 1 whole square plus dash dash m plus 10 whole square is the square of a positive integer n. Find m plus n. Okay, yeah, this looks So n square is given as m square plus m plus 1 whole square plus dash dash up to m plus 10 whole square. This is nothing but sigma of, okay, k square, where k is from 1 to m plus 10. I added 1 plus 2 plus up to m minus 1 whole square also, minus, okay, minus, you have to subtract the k to m minus 1 k squares, okay, k equal to 1 to m minus 1 k squares, okay, sigma of it, well, okay. Now we know that n square is basically, I mean, square of, sum of square of continuous integers is uh, n plus 1 into n plus 2 into 2n plus 1 by 6. So if you substitute that, what you will get is n square equal to m plus 10, okay, m plus 10 into m plus 11 into 2m plus 21 by 6 minus, okay, this is starting from k to m minus 1, right? So m minus 1 into m into 2m minus 1 by 6, okay. Okay, simplify it, you will get this value 11, n square equal to 11 times m square plus 10m plus 35, okay, which is equal to, I just want to make have a square here. So m plus 5 whole square plus 10, okay. Now n square equal to, let's call m plus 5 as x. So it's 11 times x square plus 10, okay. Now since 11 is the prime number, okay, x square plus 10 should have 11 as a factor, correct? Because you need to get a perfect square, right? So x square plus 10 should have a factor of 11 and some other square, correct? Okay. So x plus 10 should be divisible by 11. That means, okay, x plus 10 is congruent to 0 mod 11. Okay, which means if I take 10 other side, it will become x square is congruent to minus 10 mod 11, which is minus 10 means 11 minus 10, that is 1. So x square is congruent to 1 mod 11. That means x is also congruent to 1 mod 11. These are all remainder theorem logics, actually theorems. You can see my previous videos to understand completely the remainder theorem, how it works. Okay, so that means x should be 1 more than multiple of 11, okay? Or otherwise, if you divide x with 11, you will get one remainder, like 12 and then 23, like that. X is 12, 23, one more than basically 11 multiple, okay. Now x equal to 12, 23, 34, etc., which means m equal to, because x equal to m plus 5, right? So you subtract 5, you will get 7, 18, 29, etc. Okay. Now you substitute m in n square and then see where you will get the nearest value. Okay. So the least m value is 18. Okay. At 18, m equal to 18, you get n equal to 77. Okay. For m equal to 7, we don't get perfect square. So n equal to 77, m equal to 18. Okay. So m plus n equal to 18 plus 77, that is 95. Okay. Next. Yeah, this is moderate. AB are positive integers satisfying a cube minus b cube minus ab equal to 25. Find the largest possible value of a square plus b cube. Okay, a cube minus b cube minus ab equal to 25. Okay, so if you see, ABC are positive integers, which means this is the minus b cube minus ab the negative term. So it is very clear that a cube is the only positive term here, bringing the value to 25. That means definitely a is greater than b, right? If a is less than b, then b cube will be very heavy, right? So it will become a negative number. So a is greater than b. Note down that. Let a equal to b plus x. That means, okay. Then just replace. Okay, b plus x whole cube minus b cube minus b into b plus x equal to 25, which means this is the values you will get. Okay, simplifying, you will get b square into 3x minus 1 plus b into 3x square minus x plus x cube equal to 25. Okay, here x is at least 1, right? Otherwise, it will become equal. So this should be minimum of 1. Okay, so 3x minus 1 and 3x square minus x are positive, correct? Because x is at least 1. So this will be a positive number. Okay, so this is positive, positive, and positive. All three are positive terms. Okay, this means x cube should be less than 25, obviously, because 25 is made up of sum of these three terms, not x cube alone. Okay, so x cube is less than 25. So which means maximum value you will get is x equal to 1 or 2. Why I am taking only x cube value here? It's because I only have to try only with two values. Now 1 or 2. X is either 1 or 2. If you take x as 3, it will become 27. Right? So for x equal to 1, What is that you will get? You just replace this equation, x equal to 1. You will get 2b square plus 2b minus 24 equal to 0, which means b equal to minus 4 or 3. Okay. Since it is a positive integer, b equal to 3. This is one value we get. For x equal to 2, 5b square plus 10b minus 17 equals 0. So you don't get any integer solution here. You can check the determinant and find out that. Okay. So only option is b equal to 3. Now just substitute b equal to 3 for x equal to 1, right? So a equal to 4. Now a square plus b cube equal to 43. This is simple number theory question. Okay. Just to moderate, I say because you need to assume few things here. Okay. Next. Find the number of ordered pair AB such that A comma B belongs to 10 to 30 set of from 10 to 30 and GCD of A comma B plus LCM of A comma B equal to A plus B. Okay. Yeah, let's see. A comma belongs to set from the elements of set from 10 to 30. Given that GCD of A comma B plus LCM of A comma B equal to A plus B. Okay. We know that HCF or GCD of A comma B into LCM of A comma B equal to A into B. Right? Any two numbers you take, product of the numbers equal to HCF and LCM. Okay. So addition is possible only if, but they are telling it is addition here, right? So addition is possible only if HCF of those two numbers should be either A or B and LCM should be the other one. Okay. Then addition is possible. Otherwise, addition is not possible. Correct? So which means let HCF equal to A and LCM equal to B because A uh, correct. HCF is one number, LCM is basically other number. This is how you should take. So now from this set, A comma B should be 10 comma 10, where both LCM and HCF are same. Okay. Then otherwise 10 comma 20, where LCM will be 20 and HCF should be 10. Okay. So you find out all the possible values from this set where A comma B is equal to LCM and HCF of the same values basically. Okay. So basically you will get the factor numbers you will get. 10 is a factor of 10, 10 is a factor of 20. Okay. So, and it's a set. So numbers can be A comma B can be same as B comma A. So you take the reverse of those numbers also. 30 comma 10 and 10 comma 30. Then 11 comma 11 factors here, factors like that you should take. There are total 35 such pairs you will get. Okay. It's easy. Next. Suppose the prime number p and q satisfy q square plus 3p equal to 197p square plus q, where q pi b, write q pi b as mixed fraction like L m by n, okay, and then what is the value of maximum value of L plus m plus n? Okay, this is what is asking. If m and n are primes, basically they're telling this is a mixed fraction you have to write. Actually, so q square plus 3p equal to 197p square plus q, okay, which means you take q and p terms to same side. Or q square minus q equal to 197p square minus 3p. Q into q minus 1 equal to p into 197 minus 3. Okay, here you know q and p are primes. Okay, so q minus 1 is a multiple of p, has to be because q is a prime here. Okay, similarly this also should be prime of factor of this one, multiple of q. Okay, so q minus 1, let's take simple one, is q minus 1 equal to kp because it should be a factor of p, it should contain p, otherwise you will not get p from this, right? P factor you will not get, which means q equal to kp plus 1 for some k. Okay, now replace the value. So what you will get is basically kp into kp plus 1, k equal to p into 187p minus 3. Now simplifying, what you will get is 187p minus k square p equal to k plus 3. Okay. Now p equal to, from this you can write p equal to k plus 3 by 197 minus k square. Okay. So k square should be less than 197, otherwise it will become a negative number. Okay. Which means k should be less than or equal to 14. Okay. This is one. Note down one another equation. Now k plus 3 is greater than 197 minus k square. Correct. That's what it has to be. Otherwise, you don't get the integer value. Okay. Now adjusting the equation, we'll get k square plus k minus 194 is greater than or equal to 0. Okay. So k should be greater than or equal to, this is the roots you will get for that equation. Okay. So k should be greater than 13.4. This is the value you will get approximately for this. Okay. This is a quadratic equation. You solve it, you will get k should be greater than 13.4. And here k should be less than or equal to 14. So from this we can clearly see k is equal to 14. Correct. K equal to 14. So for k equal to 14, P is equal to k plus 3 by 197 minus k square, which is equal to 17. Okay. K equal to 14, right? Then Q is equal to 239. Okay. You can get from here. P by Q equal to 239 by 17, which can be written in a mixed fraction as 114 by 17. L plus L m by n equal to 114 by 17, which means L plus m plus n is 32. Okay. Just a moderate, little bit assumptions you have to make here actually and see. Next. Okay, there is a 10-digit number. Okay. And we need to obtain new 10-digit number m according to the following rule. Okay. We can choose one or two disjoint pairs of adjacent digits like 98, 87, okay, 32, 21, 10, like that, and then interchange them. Okay. 10 will become 01. Then it's a new set of number you will get it, right? Okay. So like that, and the number of pairs also can be, there can be multiple number of pairs. You can, at the same time, you can exchange 1 and 0 as well as 9 and 8. Okay. So the question is find the number of new numbers that can be obtained from this M basically if you apply the above rules. Okay. So this is simple. This is a simple permutations and combination problem. Okay. We can exchange 10 digits in how many pairs maximum? 1, comma 2, comma 3, comma 1, 2, 3, 4, 5 pairs. That's it. Because 6 pairs, the total numbers are 10 there, right? So maximum you can make is 5 pairs, which you can exchange. So let's check for the one pair. Okay. One pair, let us consider this 10-digit number as 8 digits plus one pair. Okay, 2 digits, right? So 8 plus 2, 10 digits. You will consider this as a 8 digits plus one pair. So total 9 numbers. Okay. And you can exchange these in 9C1 ways. Okay, combinations 9C1 ways. Okay. NCR is nothing but equal to 9 n factorial divided by n minus r factorial by r factorial. Okay, so you apply this, you will get the NC 9C1 value. Similarly, for two pairs, you consider 6 digits plus 2 pairs. 2 pairs is 4 digits, so total is 10 digits. Now, this is a 8-digit number. You can arrange them in 8C2 ways. Okay. Similarly, 3 pairs you can arrange in 7C3 ways and so on. So, total number of combinations you can make from the above number is 9C1 plus 8C2 plus 7C3 plus 6C4 plus 5C5. That is the total of 88 combinations you can make with this number. Okay. Next. Yeah, I think that's all. As I said, one question is removed because the question was wrong. So the level of IOQM 22 is tougher compared to 21, at least in the 2 marks questions, right? Let's see how the other questions are in the coming videos, upcoming videos. Thank you.